morning. It's wonderful to see so many people here. I see a lot of new faces. My name is Ronan. I'm a chartered structural engineer and I'm the managing director of InteliBuild, and we're a specialised BIM consultancy business. We focus purely on BIM, 3D CAD and 4D virtual construction. We have systems and processes that we've developed over the last 6 years to do design coordination, facilitate coordination and facilitate construction planning. In our office we employ architects, structural engineers, MEP coordination staff and construction planners. We have set up project teams with structural engineers to do detailing coordination, architectural teams to manage interface management, and we have an MEP team who look after all the different disciplines. Each of the teams have specific skills and specific disciplines and are led by a project manager experienced in coordination. So what I'm going to do today is I'm going to talk about two different strategies for implementing BIM, both of which are evidenced in Hong Kong. One is a client-led design BIM process, and one is a contractor-led BIM process. If you're dealing with a large construction project and a large multidisciplinary team, there is an option to do full BIM by a full design team. And what we mean by full BIM is an architectural 3D model, structural 3D model, and MEP 3D models, all from the outset of the project. The construction BIM is more predominant in Hong Kong, and it is done independently from the consultants. So the 3D models are assembled by, as Calvin mentioned, the all-star team, but they're independent from the designers. So the construction industry is, we all know, 4 phases: design, tender, build, and then operate. On Cathay, the objectives were very clear at the outset. We had a very clear goal: to save time during the design process and the construction stage, to produce a coordinated, fully detailed design clash-free, to use the technology to produce all of the construction documentation, and to reduce the client's risk of cost variations during the contract. The technology we used: Autodesk technology, AutoCAD for the cargo handling systems, Revit for the structure and architecture, and Autodesk MEP for all MEP systems. Each of the disciplines were working independently while coordinating the services. So there was this specific team for the HVAC, for the electrical, for the fire, and for the MEP. Our job as the consultant was to assist in the coordination, identify coordination problems, document them, and then demonstrate those problems to designers. To do that, we've set up very sophisticated, detailed clash analysis systems. So we have a process through which we analyze the models and we determine where there are clashes, whether there are operations affected areas, whether there are architectural design issues, whether there are MEP installation issues, or whether there are actually cargo handling facility issues. To give you an example, without going into the detail, this is a part of the building. The purple block in the middle is the operating corridor for a piece of machinery that moves. So we've modelled the operating spaces as 3D objects. On the top right hand corner you'll see during the design stage we identified drainage pipes that were passing through the operations areas. So these were objects which, when you look at a 2D drawing, you would never see. We find them in the 3D clash analysis. As a BIM consultant, with our engineering knowledge, our coordination knowledge, we help the design teams work out solutions for these. So we advise them where to relocate the pipes, we tell them what they can move, what they cannot move, and then we help them get things sorted out. From the model, we're then producing RFIs or TQs. In this example, we're demonstrating a clash between structural framing and stair systems. So you have 2 different design disciplines that we're trying to coordinate. In this case, we're dealing with escalators. The escalators, as you can imagine, the client is very keen to know where the escalators are, how the circulation works. So we're looking at the coordination of the escalators with the structure. So that was a design BIM led by a client. Now I'm going to focus purely on construction BIM presentations. To achieve that, BIM consultants have a key role to play. They have to establish a BIM team with the contractor. This is a construction BIM model. The design team have worked predominantly in 2D, and now they're going building this thing in 3D. The consultants have to bring together all the information, both from the design consultants and the subcontractors. They have to then manage and basically create the BIM models, identifying all the coordination issues, and then describing those to the clients, the consultant, the subcontractors, and then resolve and assist to resolve those issues. Hysan are redeveloping 500 Hennessy Road. This is a very large commercial development right in the middle of Causeway Bay. We're incorporating 4D virtual construction. On this project, we're working with the design consultants, 2D documentation. We're building 3D construction models. So we're modelling the architecture, structure, all the drainage, plumbing, all the electrical systems, the MVA systems, and we're also modeling the construction systems, temporary works, ELS. So if you look at the structure is quite complex. There's very, very large structural steel elements at high level. There's very, very detailed and complex transfer structures throughout the building. And then you have a basement. And I'm going to focus purely on the basement to show you how we use BIM for construction planning. So I'm not going to try and get into too much detail, but I'll just show you how we use the models. I can zoom into the building and I can look at what's happening in the hole. So I can actually position myself in the construction and see what's happening in the underground excavation. So I can look at the installation of the struts. I can get a sense of the scale by putting in some Bill and Bob figures. We have our own action men. So we use these models to show people what the construction is going to look like at different stages. So this is the completion of the excavation. We then move on to construct the footings and install the tower crane. So now you've got a situation where we're 6 months, 9 months down the road. We've installed the permanent columns, which are steel. We've got a tower crane on the site, and we have all the strutting. All of the information in this model has been derived from government-approved drawings, structural drawings, ELS drawings. We then use the software to identify construction problems by doing clash analysis. So not only can you use clash analysis for design of ductwork and pipework and everything else, we can use it for temporary works. So I can ask the software to check temporary strutting against the composite columns, and I want to make sure I've got sufficient clearance to install the steelwork. And then I can run the analysis. It will tell me that I've got 24 coordination problems. And then it will show me where they are. So it will show me examples of where the composite sections are clashing with the permanent works. So we can actually see where we're going to have to modify the temporary works. So as we're building the building, we can actually modify the temporary works to allow for the permanent construction in the future. So this is a method of using the technology to actually plan through a construction sequence, understanding when certain things are going to be installed, what the requirements are for those different systems, etc., etc. And we then use it for quantities. So we've been able to quantify tons of steelwork in the ELS, volumes of concrete in the basement construction. We've also been able to understand how much muck we're taking out, how much rock we're taking out. We've looked at it in terms of the contractor's sequence of work, so we can tell the contractor month by month quantities of materials to be excavated, so they can plan their resources accordingly. Then what we've done is we've linked the contractor's program into the BIM model, so we can look at an overall construction sequence. And what we're doing is we're taking information from Primavera, we're converting it and linking it directly to the 3D Revit model, so we're able to produce a construction simulation. The first purpose of this is to demonstrate to HiSAN how we're going to build the building. So how is the contractor going to complete the works? What's the construction project going to look like? So here you can see the excavation works. You can see the casting of the concrete basement structures. And this is all 12 meters, 15 meters below the street level. So this is street level. You can see how deep the hole is. And this job is on site. They're actually doing the excavation at the moment. Then we build the formwork system for the actual core walls. And then you can see the construction of the slab internally. So all the way through the process, we can use the technology to understand what's happening at different times and then plan for certain situations. And HiSAN have got a very, very strong safety policy. So in all on these models, you will see safety barriers, you'll see edge of slab protection systems, you'll see different construction systems, so that all the subcontractors can understand where they're going, what they're doing, and what's happening on the job site. So this shows the construction sequence. So there's a number of different works areas. So there's obviously the tower, there's a retail podium, and then there's a late area for the retail podium. The reason for the late construction here is to facilitate logistics, delivery of material, and give the contractor more working space. This is the Hong Kong U Centennial campus. We were working for Hiping Construction, and Hiping asked us to get involved with looking at purely the basement excavation sequence during the tender period. So when Hiping were pricing the job, we were helping to do a risk analysis, we were helping to do pricing to understand how to build a basement. What we've done is we've used the model, and again we've looked at a construction phasing. So this is basically looking at removing the reservoir, doing the excavation for the actual basement, doing the site formation, and then as you go down, installing all the ELS. So there's quite a lot of sophisticated ELS. This is the existing reservoirs, these are the two historic buildings, and the existing university is on this side. And then this shows basically the construction sequence for the floors. The technology is very, very powerful for getting a design team to understand all the details for the coordination. So whether it's a design model where the architect, the structural engineers and mechanical engineers are all working in 3D, or whether it's an independent model that we've created, the model is a great communication tool. It allows everybody to understand the issues and everybody to see the details. That project understanding, we've seen and witnessed great improvements in design layouts, great improvements in the efficiency of getting things coordinated. So the actual understanding of a project is hugely valuable. We've seen it being used by site surveyors. If the model is built accurately and is built to suit construction, the model can be used by the surveying team to set out the building. So they can take the 3D model, they can put it in their total stations, and they can actually lay out the building. And most importantly, because I'm involved with the Lighthouse Club and safety is one of our major concerns, we're now seeing the contractors use the models for safety assessments. They'll look at the 3D model, they'll look at different stages of construction, and they'll identify where protection screens are needed, they'll identify work sequences that don't look safe, and they'll help work the safety of it. So it's proving valuable from that point of view. We need more consultants on the design side to use BIM. The MEP consultants are the ones that are going to have to pick up the game. MEP coordination at design stage is something we don't do as an industry. We wait till the contractor's on board, and then we wait till the subcontractor's on board, and then we worry about the ductwork and pipework. In the BIM world, that's too late. So what we're having to do is we're having to bring in MEP coordination skills to the design teams and improve the coordination of MEP at the design stage. My favourite is the relationship between the designers and the contractors. Because of the historic love-hate, love relationship between these different groups of people, we're seeing design models shelved and contractors building their own model. So we want to try and improve the setting up of BIM models at the design stage so they can be given trustingly to the contractor, and the contractor can build from those models. Because at the moment we're finding a lot of people building design models and then contractors having to build a completely new model for the construction. To make BIM successful, it needs to have the full support of the owner. So you can have an architectural 3D model, fantastic, but if you really want to get the full benefit of BIM, you have to get the owner involved. My personal favourite, you need to get construction advice into the design team as early as possible on these major projects. There's too many things that can go wrong, there's too many options available for saving money. The sooner you can get pre-construction advice to a large design team, the better. And we're seeing that now in Hong Kong. The MTO are very good at it, some of the clients are good at it, so we're seeing it more and more commonly. We need to improve 3D MEP coordination during the design stage. And we need to make more use of these virtual construction systems. We need to make more use of buildability assessments to make sure that we're actually designing a building that's A, safe to build, and B, efficient. And I've gone over time. And then to finish up, my 3 requests, if there's anybody here with a genie in a bottle, we need to make more use of BIM for quantities, we need to get the designers to use BIM for sustainable design, and we need to look specifically at facility management solutions. There is no solution in the marketplace that I can take a BIM model through to facility management. There are tools that people are developing, but it's not there yet. So my 3 wishes: quantities, sustainability, and facility management. Thank you all very much.
Thanks, Ronan.